DOS, or Denial of Service Attacks, by Lance West. Denial of Service Attacks. What is a DOS type attack? Just what is a DOS type attack is a pretty fixed question. There are lots of different types of DOS attacks. A DOS attack involves exploiting operating system flaws related to vendor implementation of the TCP/IP, the underlying communication protocol for the Internet. These attacks have acquired cute names like Ping of Death, Smurf, and Tearjobs, and they were effective in crashing networks before a patch was created and the newer routers were upgraded. A DOS type attack is like a million people standing around your house, banging on every door, stopping everyone else from getting in. It causes so much traffic that the router finally gives up and crashes. Here's one of the ways a DOS attack works. A bandwidth consumption attack. In this type of DOS type of attack, the attacker consumes all available bandwidth. Moreover, the attacker needs to have access to a T1 or faster network connection. But if the attacker has limited bandwidth and the knowledge of the Internet Control Message Protocol, or ICMP, which is also a tool used for doing diagnostics over a network, they can turn other network resources into zombies and use armies of computers to attack a victim. Here's another one, a resource starvation DOS type attack. This is different from a bandwidth attack in that it uses up server resources like CPU memory, file system quotas, and other server processes. This is oftentimes someone who has already had limited amount of server resources and starts depriving other users of shared resources on the network, from temporary memory buffers to temporary files sharing locations. This type of attack makes applications hang and leads to servers freezing up. Nowadays, this type of attack can be detected early on with the current fault management tools that are in place, but you need to have your server configured and set up correctly. Programming flaws for DOS type attacks. Every application or operating system has its flaws. If a flaw is in the software package relating to TCP/IP protocols, it will get out to the hacker community and someone will write a program to exploit it. Remember the Pentium F00F DOS type attack, which allowed a user to process or crash any NT operating system. This type of attack is pretty standard today too, because there's still a lot of types of applications that have programming flaws built into them. Router and domain name server attacks. Domain name server, or DNS, has a weak authentication protocols. Just a few years ago, this made it easy for hackers to gain access to the servers, letting the hacker redirect users to a cloned website using a spoofed IP address. Example, a cloned bank login page to capture the user's personal information. In this types of attack, the attacker is spoofing the source IP address to create a DOS type condition, which is convincing the victim server to cache bogus IP address information. Smurf attacks. This was one of the worst DOS type attacks due to the amplification effect it could have on the network. In this type of attack, the hacker sends out an amplification package to see just how a network will respond. If your network is a standard Class C or 24-bit address allocation setup, the network address would be 0.0 and the broadcast address would be 0.255. The broadcast address is typically used for diagnostics. The Smurf attack uses the directed broadcast address of 0.255 to send out spoof ICMP echo packets to the broadcast address. This spoof packet makes it appear that the victim system has initiated the request. Now all the servers on the network will respond to the victim's request. The attacker sends out a signal ICMP packet, and 100 servers will magnify that request tenfold back to the originating server. Here's what a typical Smurf attack looks like. On the top is a normal connection where you have a one-to-one ping relationship. On the Smurf attack, it pings all the servers, and then all the servers respond all at once, clogging the whole network up. SYN flood or level 4 DOS attack. The SYN attack was the worst type of denial of service attack before the Smurf attack came along. This type of DOS attack floods a target system via spoof broadcast ping messages. The SYN flood attack initiates a three-way process. It sends out an SYN package from the client to the server, targeting a specific port. If everything goes well, the server will receive an ACH package back from the other machine, which sets up an established state, basically. This process exploits a built-in weakness in which a server uses limited memory resources in establishing the connection, compared to once the network is connected. So how it works is, now since the hacker has spoofed his own address in this type of attack, he is unreachable by the server. So the server is sitting there with an SYN receive mode, waiting for the return ACH package to establish a connection. It will not flush the queue until it gets a response, or the server's internal timer kicks in and stops it, which can take seconds to minutes. The diagram below gives you some idea of what happens with a TCP three-way handshake. SYN flood or level 4 DOS attacks, since most servers have limited memory space used in any one connection port queue, it only takes a small number of these types of open requests to build up which can completely disable a specific port. In addition, if the hacker has done his homework correctly and has found out all your ports that are open on the server, he can use that to basically disable all your ports. Here's your basic type DOS attack. Open up the command prompt on any of Windows machines, and let's say ping Google address. This is your standard type of DOS type attack. You ping Google's address, basically add a -T and -1 and like 15,000. The -T means ping the specific host until stopped. The -1 size is the size of the buffer you're sending. I should add that most of these type of attacks can be handled pretty easily nowadays. So here's a few recommendations. Set up a DMZ zone in your network. A DMZ zone setup adds additional layer of security to an organization's local area network land, because setting up a demilitarized zone is like setting up a sub-network. Because once they attack the outside network, it's easy to disconnect that sub-network. This is a setup of your typical DMZ zone inside your local corporation or company. Defending against DOS. The usual defense against a DOS type attack is to try to figure out who is sending your server requests and block them one by one. The problem is that it takes time to figure out who is doing the attack, and in the meantime your websites are effectively inaccessible. A new defense against a DOS type attack is called SpeakUp. The defense works by asking all clients connected to the server to pump up the size of their requests. So instead of trying to distinguish between friend or foe on the traffic, it simply asks all clients to send it more and more traffic. The theory goes is legitimate clients will have ways of more available bandwidth than the hacker does, who are probably maxing out their bandwidth while trying to shut you down. As a result, legitimate clients get more of the server time, enough hopefully to prevent a service interruption. SpeakUp works like this. At the top illustration, you have a portion of the server resources being used by legitimate traffic in black. When the server is under attack and undefended, as the bottom part sees, you got the same server with SpeakUp in place. Now the legitimate traffic is getting its fair share of the server resources and stopping the hacker from taking down the network. The end. Helping to bring modern civilization to its knees. I hope you liked the presentation. Thank you.